Hey again, it's Mr. Lum again, and we're going to be doing some more electrochemistry. Today we're going to be learning how to balance redox equations using oxidation numbers. So last time we balanced redox reactions using half reactions. So we would take a reaction like this one, we would split it into two pieces. So one piece would be SeO3 minus, making Se, and the other piece would be I minus, making I2. And then we would balance those two half reactions, multiply to get rid of the electrons, and then add them back together, and that would be our balanced redox reaction. Okay, this time we're going to do it a little bit differently. We're going to use and calculate oxidation numbers, and from these oxidation numbers we're going to balance this. Now, how can we do that? Well, here it is. So, in a redox reaction, the oxidation number of one species is increasing. Remember that? Oxidation number of one species is increasing. Or in other words, something is being oxidized. And the oxidation number of another species is decreasing, or something is being reduced. Okay? So what we can say is that if something is losing electrons, okay, or being oxidized, if something is losing electrons, then whatever is being reduced must gain those electrons. So if something is losing 3 electrons, then something must be gaining 3 electrons. And we're going to use that principle of having the overall change in oxidation number equaling 0. We're going to be using that principle to balance our redox reaction. So, first step right here is, in balancing this one, using changes in oxidation number, is balance the majors. Okay, so I'm going to rewrite this reaction. SeO3 2 minus plus I minus makes so what we see here is that Se and Se, they are the same, so no balancing required. Now here we have 2 I and only 1 here, so we're going to put a 2 in front of there. Okay. Now we're not going to worry about our oxygen because that is not a major yet. Okay, we're just going to worry about the majors, which is Se and I right here. Okay, so our majors are now balanced. Now what we're going to do is we're going to calculate the change in oxidation numbers. So first calculate what is the oxidation number of Se right here. So if I write, say, SeO3 2 minus right here, what we can say is this is going to equal minus 2. And this is going to be, oxygen is minus 2. Now there's 3 oxygens. Okay, so that's going to be a total of minus 6. So minus 6 equals minus 2, so that means this has to be a plus 4. So 4 plus minus 6 equals minus 2. So our oxidation number of Se right here is 4. Okay. Now, our oxidation number of this Se right here is 0. So how did this change? Well, it went from 4 to 0. So that means it had to decrease by 4. So the change in oxidation number, so oxidation number change, this symbol delta means change. Change in ON, or change in oxidation number, is minus 4. Now let's look at the change in this one. We have I minus, and so the oxidation number of this one is minus 1. And the oxidation number of I2 is, well, that's easy, 0. So what is the change in I minus? It goes, now here's a little secret, is that there are 2 of these. Okay, so this one has two I minuses. Okay, so what it's happening is that this number, the change in oxidation number, it is clearly getting larger. So this is an increase in our oxidation number. So this is losing electrons. This is oxidation right here. It's losing electrons. And how many electrons is it losing? Well, each I is losing 1 electron. So there are 2 I's. So the total amount of electrons that are being lost is 2. Okay, so the 2 electrons are being lost because there's 2 of these ones. So the change in oxidation number is plus 2. Okay, so what we now need to do is we've calculated the change in oxidation number. We need to make them equal and opposite. So if this one is gaining 4 electrons, this must be losing 4 electrons. So we need to multiply this half reaction by 2. Okay, so I'm going to do that right here. So we're going to go SeO3 2 minus plus. Now I'm going to multiply this by 2. So it's going to be 4 I minus makes Fe plus 2 I2. Now what we see here is that now the change in oxidation number of Se is minus 4, and the change of oxidation number in I minus is also equal and opposite, or plus 4. So this one is gaining 4 electrons, and this one is losing 4 electrons. Okay? And now what we need to do is we need to just add H2O to balance the oxygen right here, and H+. Okay, so we're going to add H2O and H+. So I'm going to rewrite this equation one more time. So SeO3 2 minus plus 4 I minus makes Se plus 2 I2. We have 3 oxygens right here, so I'm going to add 3 water. Okay, so now oxygen's balanced. Now we need to balance our hydrogen, so I'm going to add 6 H pluses. Okay, and that's it. You don't even have to look at the charges because they should be correct, but just to make sure, well, let's check everything out. Okay, so we have 6 plus right here, minus 4, minus 2, so the total charge on this side is 0, total charge on this side is 0. The majors are balanced, Se and Se, good. 4 I's and 4 I's, good. 6 hydrogens, 6 hydrogens, 3 oxygens, 3 oxygens, everything is balanced. Majors, oxygens, hydrogens, and charge, all balanced, and that's why this is our correct answer. Okay?